Problem number 60, it says the time it takes for an object dropped from the top of a cliff A to hit the water in the lake below is twice the time that it takes for another object dropped from the top of cliff B to reach the lake. All right, I remember doing this one last year. This one's kind of a hard one, so put on your thinking caps. Okay, so here's what we're going to do. Shh. If A, shh, listen, it says it takes twice as much time. So we have cliff A. So if it takes twice as much time, what can we assume about cliff A? It's taller. It may be twice as tall. We don't know yet. Okay. To reach the lake, and then it says for part A, the height of cliff A is 1/2, 2 times, 4 times of cliff B. If it takes 1.8 seconds for the object to fall from cliff A, what are the heights of cliff A and B? So if the time for A is 1.8 seconds, what is the time for B? Which is?
0.2 divided by 2 times it by 2 times by 4.
So, no, listen to me carefully. It says, let me read it again, you guys got to think. The time it takes for an object dropped from the top of cliff A to hit the water in the lake below is twice the time it takes for another object dropped from the top of cliff B. So if it takes 1.8 seconds from A, how long will it take from B? 0.9. Good, that's what I was looking for. So what we're trying to do is to establish...
Can I go to the bathroom?
Sure. I'm trying to establish the height of the cliff, and then we'll go from there to see what's the difference. Now, I think when we said because the time was twice as high, we made the assumption that the cliffs would be twice as tall. And that's not a bad assumption, but we're not for sure. So basically we're going to drop a rock from here, and we're going to drop a rock from here. If I drop it from cliff A, it's going to be 1.8 seconds till it hits the water and splashes. Okay? If I drop it from cliff B, it'll be 0.9 seconds. And then it asks us, there's some sort of proportionality. Is it 1/2? Is it twice as much? Is it 4 times? What's the relationship between the two cliffs? We only have the time. Or do we have more information? Okay, what do we know? They didn't tell us anything other than the time, but what else can we figure out? We know that V naught is equal to 0 meters per second. Any object in free fall will have an acceleration . Okay, and that's the same for both rocks, right? A and B, right? We don't know the final position, and we know the times. So what we can do is we can go to page 59 in our textbook and try to calculate the distance or the height of the thing. Oh, okay. So there's this one here. Could we do this one? If I said y is equal to y naught plus v naught times t minus 1/2 g t squared. So if I use this formula, we would say g is equal to 9.8. All right, because the formula in the book has been written differently. Right? They just put the negative sign in the formula. Normally this formula, if we put an a in here, it would have a plus sign. We just don't want to subtract it twice. All right. So what's y naught for cliff A? 0, right? So we've got y is equal to 0 plus, what's the initial velocity? 0 times the time, which is 1.8 seconds, minus 1/2 times 9.8 meters per second squared, times the time, which is 1.8 seconds squared. Alright, so this term goes away, this term goes away, and I get my final position is equal to negative 1/2 times 9.8 meters per second squared times 1.8 squared. So let's pull out our calculator for that. 1.8 squared, 3.24 seconds squared, right? Because the s gets squared as well. All over 1. So now I've got to multiply across the top. Oh wait, look. My seconds cancel, right? This cancels with this. So my final answer should be in meters, right? So I've got across the top, I've got 9.8 times my 3.24. And that gives me 31. And then I got to divide by 2 because of the 2 here, right? So cliff A has a distance. Now why is it a negative distance? Well, because going up is positive and going down is negative, right? So the height of the cliff is 15.86 something. So now what do I got to do to compare the two? I got to do the exact same thing with cliff B, but I've got to use the cliff B information. So for cliff B, hey father, for cliff B what we need to do is it's the exact same equation. I'm going to write it purposefully the other way. And so we've got y equals, what's the initial position for cliff B? 0. Initial velocity for cliff B? 0. The time now is going to be 0.9 seconds, right? Plus 1/2 times the acceleration due to gravity, which is -9. We're going in the negative direction, right? Meters per second squared, times the time, which is 0.9 seconds, which is squared, right? Is that right? All right. So this term goes away, this term goes away, and I get y is equal to 1/2 times the quantity 9.8 meters over second squared, and then this 0.9 squared business, right? So we're going to say 0.9 squared, and I get 0.81. And that's second squared all over 1. So what happens to the second squared, you guys? Cancels out, right? So these cancel. We're looking for a distance. Oops, I got a little cancel crazy. Canceled out my 0.81. I just wanted to cancel the second. So I'm going to have 9.8 negative, yep, times, let's put it in there so you guys know what we're doing. Negative 9.8 times 0.81. Well, that's what would be in the numerator, but then I have to divide by 2, right? Because I have this 2 here. Alright, so let's divide by 2. And I get, oh wow, that's significantly smaller, isn't it? It is negative 3.969, and we have meters left, right? So when we compare the two answers, I've got for cliff A, right? For cliff A, this is cliff A, and this is cliff B. So let's just kind of refresh or kind of go over what the original problem was. The problem in the textbook said it takes twice as long for an object to fall and hit the water below when it's thrown off a cliff A. It takes 1.8 seconds. and it takes half as long from cliff B, which was 0.9 seconds. And then we were asked to determine, like, what's the ratio, or is it proportional? Like, what's the difference in the height of cliff A and the height of cliff B? And so what we did is we just calculated the two heights. So what do you think the difference is? Is it 4? It's roughly. So cliff A is roughly 4 times taller. Why do you think that is? Zach?
Because the
We'll talk about it tomorrow.